lesson to put on your homework I assign on Tuesday. So let me say that again. The homework I assign on Tuesday, there will be some problems that I will get from the review preview down here, probably the first two maybe, but I'll probably get a couple problems from here so we can make sure, I can make sure you understand this lesson. So keep that in mind. And again, Devin, if you can't stay the whole meeting, it's okay. Just look at, if you're confused on anything when you see the homework next Tuesday, just look back at this video. I post them all always. So compound probability, there's not a big difference here between what we did. It's just we're talking about compound probability means more than one thing happening. So it's just multiple probability. Compound is multiple things happening, multiple events. So as this says, it says we're looking at probabilities of compound events. And when I click on that, it says a compound event in probability is an outcome that depends on two or more things, events or possibilities, like the probability of something happening. So the probability of a red ball and blue block would be compound. You're looking at if you could get that or the other. So you want to look at the chances of getting either one. So it's basically saying either one is fine. That's what you're saying for compound probability. So I'm just going to go through some of these problems, and I'm going to ask you guys to help me out on here. Now this document doesn't work well because I can't really write on it. So what I did is I copied this on here. Can you guys see? Chat to me. Tell me, can you see the piece of paper I'm showing right now? Or do you still see the ebook? You don't? Okay. So what I have to do, let me do a new share. Let's see. Here it is. Okay. I wasn't sure how that would work. So now, where did it go? Hold on. You see dogs? Okay. Hold on. How about now? Do you see a document with some red typing on it? Good. Okay, that's where I wanted to be. Perfect. Thank you guys for helping me out. So what this is just, this is the lesson compound probability. I basically took screen pictures of these and I pasted them in here because then I could write your answers in here too. So basically this is on compound probability. So we have Thomas. Thomas, you're the star of our first problem. Thomas helps out around the house by doing one chore after school. Each day, Thomas and his aunt use the spinner to decide which chore he will do. These are the choices. You see rake leaves, do laundry. Now, one thing to keep in mind, I know it looks a little stretched out, rake leaves and do laundry are the same size. Even if they look a little different, we're just saying they're the same size. You have clean bedroom and vacuum and clean bathroom. They're also telling you that clean bathroom and vacuum are the same size. So the first thing I need you to do on your paper is write down the fractional probability for vacuum, which is 1/4, bedroom, cleaning bedroom, 1/3. Bathroom is the same as vacuuming, so that also be 1/4. And now what I need you to do is tell me what is the probability of doing laundry. So take a couple minutes and work it out on your paper. Try to figure out what's the fractional probability of getting do laundry. Type it in when you think you know it. And I'm not going to say right or wrong until I get more than a few responses of what you think. Now again, they're telling you that you know the one, I'll give you a clue, clean bathroom and vacuum is half of the wheel, so that's 50%. Bedroom is 1/3 of the other half, and then you only have a little bit left there. Do laundry and rake leaves, you're looking at the entire wheel. What fractional part is laundry? I'm seeing a few right answers. The 1/8, we've got to rethink. I like what John did. Now, I want you guys to try to do what John did. He knew, or he figured out, that he had to get a common denominator. And that's the big thing for compound probability. You got to find common denominators. So he used the common denominator of 12. And what he did, I think, and I'm assuming, what he did is he changed every one of these fractions, like for example, 1/4. This will take me a little bit of time because I have to write this. He made this with 12 as the denominator. And so if he does that, thinking giant 1, he knows that that would be 3/12. So if the 1/4 are actually 3/12, it's really fun to do. Then the clean bedroom, what would 1/3 equal when I make the denominator 12? Good, I see people typing 4/12. So clean bedroom is 4/12. So look at what I'm doing, because I see people typing the right answer in now. So if this is 4/12, this is 3/12, we know this is the same as vacuuming. This is 3/12. All you have to do now is think how many 12ths are left. Well, if I have 3 plus 3 is 6 plus 4 is 10, that's 10/12. So when you typed in 1/12, John was right here. I know other people are getting it now, but I saw John got it first. So rake leaves is 1/12. That means do laundry also has to be 1/12. Daniel, don't make me shut you off. I have power. Thank you. So that is correct. Good. And notice when you add up every 12th here, and write that down if you want. I'm not moving that yet. But notice when you add up every 12th, you get a total of 12 out of 12. And that's the important thing. You have to look for common denominators. So for compound probability, common denominators are really important. If you don't find a common denominator, it will not work. Any questions on that problem? Let's look at B on that. Thomas hates to clean the bathroom. Tommy, you hate cleaning the bathroom? When he spins the spinner, what is the probability that he won't have to clean the bathroom? I never cleaned a single thing in my life. Well, I'll be emailing your mom later. Anyways, so what is the probability? Now be careful, because the word not is important. So what's the probability of him not having to clean the bathroom? So look at clean bathroom down here. I want the probability of not cleaning the bathroom. Careful with your adding. I'd actually accept 2 answers for this. There's 2 different answers I'd pick for this. So think you have 12 out of 12 is the total. And you have to subtract out clean bathroom, which is 3 out of 12. So the answer could be 9 out of 12. Or if you simplify 9 out of 12, what do you get? Now, Daniel, you went the other way. You multiply by 2, which technically isn't wrong. But if I simplify 9 over 12, that equals, good, I see people typing it, that equals 3 over 4, because 3/3 goes into this. So you can say there's a 3/4 chance. The probability of not getting clean bathroom is 3/4, or the probability of not getting bathroom is 9/12. Either one is correct. Technically, 18 over 24 is right also, but usually we're simplifying fractions and not making them larger, but it's technically correct. So either one is good. Questions on that problem? Oh, good. The writing moves up. Now let's look. Tommy's busy. Tommy's aunt hopes that he will either spin clean bedroom or rake leaves today. So first off, we know the probability of clean bedroom is 4/12. And we know the probability of rake leaves is 5/12. So this should be easy. Now this is compound probability. So what his aunt will be happy if he gets clean bedroom or rake leaves. So when you hear or you have to do compound probability. That means you're adding. So if you combine clean bedroom with rake leaves, what do you get? So if you combine clean bedroom with rake leaves, you get, did I say it out loud? No. Not 4/12. 4/12 plus 1/12, so good. It would be 5/12 because you're doing combined probability. Now, how you write this is different too. Let me see if I could insert a text box. Oh, let me do this, please. Yay. No, it's not going to let me. There it goes. So when you're writing a probability statement, this is, again, remember for probability, you always do a capital P. So write this down. This is how you would write the probability for clean bedroom or rake leaves. So you'd write capital P, and in parentheses, you put what you're looking for. So for this, since it's either one, you'd write probability clean bedroom or rake leaves. Let me make this a little bigger. And then you close the parentheses, and you put your equals. And at this point, you're going to put your fraction. So that would be 5/12. Okay. So that's how you write your probability statement. That's going to be important next year, is to remember to know how to write probability statements. And you've seen them on your homework already, and you see them in this lesson too. Probability statements always have a capital P to show its probability, and in parentheses, they tell you what you're looking for. So that's how you're usually going to see it stated. The word or is important because there's 5/12 of the wheel that has those two things on it. So either one is good. Now you learn more complicated probability next year, but for now, we're having a choice. We're not taking away anything from the wheel. We're just saying those choices are staying. The chances are 5/12 of the time he'll get one or the other. So that's how you would write two outcomes, as it says here. How can you write two outcomes as a single probability? That's how you can write two outcomes as a single probability, by writing the statement like that. Any questions on how to write a probability statement, a combined or compound probability statement? Okay. Now, this is the last one I want to do for today. And this is about a deck of cards again. And now we did a deck of cards example last week too. Let me move this over so I could see it better. Oh, they're not going to let me. Okay, I'm not going to worry about it. So we did compound probability before. And what this says is Steve shuffles a standard deck of 52 playing cards. So these are the first ones he's turning over. Now this one is different. We're not keeping the cards in the deck that we're removing the cards he draws. So we're not picking a card and putting it back in the deck. So think about what happens to our denominator for this problem, okay? So for this, it says the first three cards he turns over are an ace, a 4, and a jack. So now what we're going to do is you're going to tell me first how many cards are left in the deck. That's just a number answer. It's not a fraction. So if he has 52 cards, and the first three cards he turns over are those cards, how many cards are left? Yep, 49. I see a lot of people putting 49. Hold on, let me get my drawing tool back. Draw. It's not letting me. I just want to draw. There we go. So that would be 49. 49 cards left, good. How many cards in the deck are aces that are left? So next question is, how many cards are aces that are left in the deck? Good. And you have to know something about a deck of cards. Know that there's always 4 of each type of card. So there's always 4 kings, 4 queens, 4 threes, 4 twos. So everything has 4 when you start. So good. There would be 3 aces left. So you want to put 3 for B. B would be 3 because there's 3 aces left because they already removed 1 from the deck. Okay. What is the probability that the 4th card will be an ace? Now C is different than B. Now we got to write a probability statement. I want you guys to try to write a probability statement for that. Try to type in something like I did here in the chat. So I want the probability of getting an ace. And remember, probability has to be fraction or percent. Fractions are fine for today. And be careful because we remove some of the cards. So take a minute or two to type. Think about that and type what you think makes sense. And I'm going to try to find my drawing tool I need while you guys are thinking. And I'm not going to say right or wrong till I get a lot of different answers there. Let me pull the chat back up. Let's see what you guys had. So I see, let me go back up here. So Kay, you said probability, parentheses, getting an ace equals 3/49. I see John, you said probability, parentheses, drawing an ace, 3/49. 3/49, 3/49. Probability, parentheses, ace equals 3/49. Now, if I was picky, and I see Miles, you fixed yours a little. Yeah, the thing you hear in the background is my husband on a different Zoom call with his teacher. So yes. So this is, if I was super picky, this is what I would say you would have to have. Now, I don't care the way you write it as far as having an ace, drawing an ace. You can just write this, and that's good. Having an ace, drawing an ace is fine. And then you put the equal sign, and then you have 3/49. Again, it has to be 49, which you guys realize because there's only 49 cards left. And it has to be 3 because 1 ace was drawn already. Can you say 3/4? No. Can someone before, sorry if I'm frozen. That happens sometimes. Who could explain to Viv, without me explaining it, why it can't be 3/4? Why the probability of drawing an ace has to be only 3/49? It can't be 3 out of 4. Anybody could type a reason before I explain it? Oh, good. See, Viv, you figured out. Okay. Yes, it's because there aren't 4 cards left. You have to look at the whole deck. So if you have 49 cards and there's only 3 of those that are aces, and there's 49 cards total, always think your numerator is what you want. The denominator is the total of what's left. So numerator is what you want. Denominator is how many you have of that, just like a normal fraction. Now, and then D, let's look at D. Instead of getting an ace, he gets a 2 as the 4th card. And then the 5th card is a 5. So what it's asking, I got cut off here a little. What is the probability the next card will be a king? So this is a little bit, this is probably more of a tougher one to think out. Oh, no, sorry, everything's jumping. Let me get rid of all this. Hold on, guys. Clean this all up. So again, what we're looking for is we want the probability. So we have our 49 cards. He goes back to the deck. He draws a fourth card, that's a 2. He draws a fifth card, that's a 5. Now, what is the probability of getting a king? So you have to look back and see what we've drawn out of the deck already. And now tell me the probability of getting a king. So write that as a probability statement again. So don't write just the answer. I want you to get used to writing the probability statement. Think about how many kings are left. Think about how many cards are left in the deck of cards. I'm gonna get my text box down here. It'll make my life easier. So this is for D. I see a lot of you guys are getting it. Probability of a king. You can say drawing a king. In parentheses, you word it as specific as you want to be. Again, I see a lot of you figured it out. The denominator would change and the numerator would change. So since they drew 2 cards out, our denominator, or total cards in the deck, is now 47. And our numerator would be how many kings are left. Well, it would be 4 kings left in the deck because we haven't pulled any cards and any kings out. We've pulled an ace out, a 4, a jack, a 2, and a 5, but no kings. So there's 4 kings. But notice the denominator has to be 47, Colin, because they got rid of 2 more cards. So your denominator has to be 2 less. Yes, Tommy. So Tommy is saying, no, wait. Yes, Tommy, I understand what you're saying. Tommy's saying that if you want to be more specific, you could say the probability of drawing a king of spades. If you know what a deck of cards look like, you know there's 4 suits in it. So a king of spades would be 1 out of 47. Yes, so if you get really technical, there's a lot you can do with this. Let me add one more on before I stop. I'm going to write this probability statement, and you answer it in chat. So what's the probability of not drawing a, no, let me make it tricky. How about a 2? So type what you think. Now I'm going from 47 cards left, but what's the probability of not drawing a 2? So this is a little different. So think about it. I don't want to know how many 2s are there. I want to know how many cards are not a 2 that are left in that deck. So, okay, think about it again. Because you're telling me the probability of drawing a 2. I want the probability of not drawing a 2. So this is a little higher level. So you got to look back here and think what our 4th card was. Oh, it was a 2. So think about that with your answer. And now I want the probability of not drawing a 2. Not saying anything else until I get more answers. No, I'm seeing some differences. I'll explain. I'm going to give another minute, little less than a minute, to think about what everybody else is typing and thinking about if you agree with them or you're going to stick with your answer. Okay. First thing I'm going to tell you is the denominator should be 47. Now, the denominator is 47 because we didn't take anything else out. Now, the numerator, you got to think a little bit of subtraction. If there's 47 cards in the deck, you got to think in the deck, there's only 3 2s left in that deck, because right here, we already got rid of one of the 2s. So there's only 3 left. So because of that, we do 47 minus 3, and you would get 44. So that would be the probability of not drawing a 2. And that's a little bit trickier because you have a lot going on. You got to look at all the information, and you got to make sure you're using that all into your decision. Any questions on that? Does that make sense? Anything not clear on compound? So I will put a few of those problems on next Tuesday's homework. And then I'll also put things on surface area, which we're only meeting once a week now. I highly suggest being here for surface area because surface area is tricky. It's not impossible, but there's lots of steps and it's a very visual lesson. I think I told you guys, if you were here last week, that for surface area, a little art project if you want to do it. If you have a little tissue box or any kind of box and you have some paper, see how you make something like you cover the box. And if you want to try this at home, you can. You don't have to. I'll do this next week too. And see how I made the two yellow, the top base and bottom bases, I made the same color. The two side faces, I made the same color. And then these two side faces, I made the same color because they're the same area. This will really help you understand surface area. So if you want to do a little art project to do this ahead of time, if you're more a hands-on concrete learner, like you like having something in front of you, because we would have used these in class to help you out, I suggest making something like this. It's not required, but it'll help you. Any box will do. And you notice this is just a rectangular prism. It doesn't have to be a cube or anything, just a normal tissue box or anything. But if you don't have to, but this is a good thing to do. But surface area is a little tricky, and we're going to do that next